Okay, good afternoon. This time around, we are faced with an earth geometry question that is typically based on time calculation. Now, remember, time calculation mostly comes in paper 1, and it's a very vital part of earth geometry question. So come with me as we see how we can calculate time of two places that are on different longitudes. So this question is coming from 2019 paper 1, and the question says the diagram below shows the position of A, B, and C on the Earth's surface. So as we can see, we have the positions A, B, and C over there. So the question 1 says, if it is 8:20, if it's 8:20 at A, so right here the time is 8:20. What time is it at C? What will be the time at this point C? Okay, so to do that, we first have to come up with something that looks this way. We are having two places we're comparing their times with. The first one is point A and the other one is point C. These two points on top, we're going to put the longitudes, and right down here we'll be putting the time. So what's the longitude of point A? So point A, as you can see, point A is on longitude 20 degrees east. So this is 20. Just write typically the number, not just the hemisphere. Then on C is on longitude 95 degrees east. So I'll go ahead and write 95 there, like that. Okay, so according to this topic, we should know that every 15 degrees is equal to 1 hour. Every 15 degrees make up 1 hour. Okay, so all we have to do now is to find the difference between these 2 points, and then we'll then get that degree, and that's what we use to divide by 15 so that we have the hours that we're looking for. Okay, so if you look at the point A and C, they are both on the same hemisphere. They are both on the same side. They are both on the east side. They are both on the east side. Okay, so to find the difference of two places that are on the same hemisphere, all we have to do is to subtract. So we'll be subtracting these two so that we find the difference. So we'll say 95 minus 20. So 95 minus 20, what does it give us? 75, I should say, gives us 75 degrees. Okay, so therefore these 75 degrees will then be divided by 15. Like I said, every 15 degrees is equal to 1 hour. So out of the 95 degrees we have, we then want to have hours. We want to convert them into hours. So remember, 15 has to be divided by 75. So we'll be saying 75 divided by 15. Okay, and 75 divided by 15 gives us what? Is it 5? Should be 5 hours. Okay, so it gives us 5 hours. So these 5 hours that is here indicates that the time difference of point A and C, these two places are apart from each other with 5 hours. These 2 points are apart from each other with 5 hours. Therefore, to find the time at C, all we have to do is to know where we're coming from and where we're going. So if you look at these two, the question is saying at A, the time is 8:20. So right here, we have time 8:20. What will be the time there? We don't know. So we are coming from A, going to C. If you check on the Earth's surface here, A is actually inside and C is outside. So A is a bit far away from the east side compared to C. Because if we have the great circle right here, you'd notice and you'd agree with me that this is the west side. So A is closer to west than C. C is a bit further from west than A. Therefore, we are moving from A going to C. So as we move from A going to C, which is more far away from east, we are going to add time. Because from this topic, the idea is as we go up to the west, we gain time. And as we go far away from east, as we go to west, we lose time. So here we are coming from A going to C. So it's like we're going to add time. We're gaining time because we're going to east. We're going to a place that is further away from west. I'm sure you can see these two places. Okay, So these 5 hours that we have should be added to 8:20 so that we know the time at C. So to do that, we'll simply say 8:20 should be added with 5 hours. And when we add this, we should be able to get 8 plus 5 gives us a 13. So it's like that. Okay, so at point C, the time should be exactly 13:20. Thank you.